Here I am showing you on one side the muscle spindle. I was trying to describe you the central and part. We have nuclear bag fibers, nuclear chain fibers. That means that stick-like things, nuclear chain, and the bulb-like things are nuclear bag fibers. And in the polar region, we have those group 2 fibers or secondary nerve endings. You can see that. So we have in the bottom here on the left side, Golgi tendon organ. This is just like a ramifications of these terminals to the different components of the Golgi tendon or fascia, and they detect the stretch or attraction. Then on the right side we have the joint here. In the joint we have the Golgi tendon organs also, because fascia is there, and we have Ruffini end organs, the Pacinian corpuscles, and the free nerve endings, so on. Just to remind you about the muscle spindle, at rest it is firing not as much. In the bottom there is a stretch. When there is a stretch, the primary endings will provide continuous burst of activity, the spurt of activity you see on the top location. Then secondary endings, they increase the discharge continuously or tonically. The secondary endings, in fact, they are not adapting as much as of the primary endings. In the bottom we have these Golgi tendon organs, the receptors. You can just see when the muscle contracts, when it's the contraction of the muscle or a tension developed by the muscle at its peak, you will see the discharge. As the muscle tension is decreasing, the discharge decreases. So that means it prevents the rupture of the muscle fibers if it is rigorously contracting. Let us consider what are the pathways for conscious proprioception. Already we know, because these are conscious proprioception are carried by the posterior column sensation. Just briefing here, the receptors are Ruffini end organs, Pacinian corpuscles, free nerve endings around the joint, carried by group 2 or A beta fibers through the dorsal root ganglia to the posterior column. Then after giving a collateral in the spinal cord, they ascend in the fasciculus gracilis for the lower limb, fasciculus cuneatus for the upper extremity as described earlier, and relay in nucleus gracilis and nucleus cuneatus in the medulla, respectively. After the relay, the second order neurons generate, or these second order neurons, the axons of these second order neurons, they cross to the opposite side and ascend as a medial lemniscal fibers to relay in the ventero-posterior-lateral nucleus of the thalamus. The thalamocortical fibers are, that means after the relay, the third order neuron starts from thalamus, and thalamocortical fibers are relayed in sensory cortex area in the parietal cortex, area 312, or what is called the somatosensory area number 1, with a definite topographical representation, with the as in homunculus of the sensory sensations. The outputs of S1 are relayed to S2 and somatosensory area 5 and 7 for further analysis, wherein we can tell about the joint positions or the position of the limb in a particular type of motion, when a particular time of motion are either static or dynamic, or we can also tell about how severe is the force of contraction or how severe is the activity. That also, all these parameters are all attributes regarding this motion or this thing, how much is twisted, how much bent the particular joint has taken place. All those attributes, you can see them here in this analysis. For this, you see the details in the posterior column sensations in my previous lecture. Just to summarize, here I have taken the picture from the previous lecture. The receptors for touch, pressure, proprioception and vibration, they are coming here, and they ascend in the fasciculus gracilis and fasciculus cuneatus, you can see there, and reach without crossing up to the medulla in the dorsal column fibers, the fasciculus gracilis and fasciculus cuneatus. In the medulla, they relay in the nucleus gracilis and nucleus cuneatus, then cross over to the opposite side in the medulla and ascend to thalamus as a medial lemniscal bundle. In the thalamus, they are relayed in the ventroposterolateral nucleus of the thalamus. From there, the third order neurons begin and they reach the parietal cortex in a definite topographical location. Subsequently analyzed with the S1 and S2. The details you can go with the posterior column, any other posterior column sensations, where the attributes of a particular motion, action, joint position are all monitored or can be detected or specified. Let us now consider the unconscious proprioceptive pathways. Receptors are already described. They are from muscle spindle, Golgi tendon organs, Ruffini end organs, Pacinian corpuscles and free nerve endings, so on, around the joints, tendons and the fascia. The fibers carrying these receptors include the large diameter A alpha fibers, group 1A, 1B, A beta fibers, A delta fibers that will reach through the dorsal root ganglion. There are basically two different type of pathways reaching the destination point, that is cerebellum. One is direct pathway, another is indirect pathway. The direct pathways include 4 pathways. These are ventral spinocerebellar tract, dorsal spinocerebellar tract, rostral spinocerebellar tract, cuneo-cerebellar tract. The ventral and dorsal spinocerebellar tract carry information from lower limb and trunk. Rostral and cuneo-cerebellar tracts carry information from upper limb and neck. The ventral spinocerebellar tract and the rostral spinocerebellar tract, they carry similar type of sensation. Dorsal spinocerebellar tract and cuneo-cerebellar tract, similar type of sensation. These are the direct pathways. The indirect pathways include the pathways reaching to inferior Olivery nucleus, that is Spino-Olivery tract. From the Spino-Olivery tract, they will reach to cerebellum as a olivocerebellar pathways. On the right hand side, I had given the plan of various tracts in the spinal cord transverse section, and on the lower various laminar pattern of the spinal gray matter is provided. Now we will consider the direct pathways. One of them is the dorsal spinocerebellar tract. This originates from the proprioceptors of the lower limb and trunk. That means the spinal segments, the thoracic and the lumbar segments are involved. Through the posterior root ganglion, the fibers enter, and in the dorsal gray matter, dorsal horn gray matter, they relay in 1-5-7 lamina of the spinal cord, especially on the marginal side. And this nucleus is known as a nucleus propriosis. The second order neurons from these, they will traverse in the lateral funiculus on the same side as dorsal spinocerebellar tract, because they are placed on the posterior side or a dorsal side. That is marked here, that is shown in the transverse section of the spinal cord also, that is shown in the left hand figure where they are going. The second order neurons ascend up to the medulla. In the medulla, via the inferior cerebellar peduncle, they relay in spinocerebellum as mossy fibers. The area of the spinocerebellum represents the lower extremity. The ventral spinocerebellar tract also receives inputs from lower limb proprioceptors, especially from segments, lumbar and sacral segments. Major proprioceptors for this tract are the Golgi tendon organs. These fibers, through the dorsal root ganglia, enter the dorsal root and relay in Clark's nucleus or Clark's column, marked as a blue area in the gray matter. After the relay, the second order neurons cross to the opposite side, ascend in the lateral funiculus anterior side, marked as a cross there in the transverse section of the spinal cord and marked as a fiber there with a cross. These fibers ascend in this tract, that is ventral spinocerebellar tract, reach the pons and relay in the spinocerebellum. Again, what happens? That enters into the superior cerebellar peduncle and crosses again to the ipsilateral side. That means the sensation originating from the left, now it crossed, ascend as in the right side, ascended up to pons. Again in pons it crosses one time and reaches the same side, left side of the cerebellar hemisphere, and relayed into the spinocerebellum. The fibers are again the mossy the fibers, these are carrying or entering the spinal cord as mossy fibers, representing the lower extremity. Rostral spinocerebellar tract, it is from the upper limb and the neck proprioceptors. They relay, as in case of posterior spinocerebellar tract, in lamina 1, 5 and 7 of the spinal cord, ascend in the same side without crossing. However, these fibers are located rostrally in the dorsal spinocerebellar tract and they reach up to the medulla. After reaching the medulla, through the inferior cerebellar peduncle, they relay in the respective nucleus of the spinocerebellum, representing the upper part, that means the upper limb and the neck. Cuneo-cerebellar tract, these carry the proprioceptive inputs from the upper extremity, especially the upper limbs and the neck. They ascend with the fasciculus cuneatus on the same side, along with the other posterior column sensations, up to the medulla. From the medulla, they will relay, these fibers relay into the lateral cuneate nucleus. The lateral cuneate nucleus is also known as the external cuneate nucleus or the accessory cuneate nucleus. And the axons of the second order neurons enter the cerebellum via inferior cerebellar peduncle and reach the spinocerebellum as mossy fibers, representing the upper extremity of the same side. Now coming to the indirect path, carrying the unconscious proprioception. These are Spino-Olivery tract. The origin of the Spino-Olivery tract begins with the proprioceptors from all segments of the body. That means starting from the cervical to the lumbar sacral regions, all the muscle spindles, the Golgi tendon organs, the ligament, free nerve endings, so on. All the receptors are coming with this tract. They reach through the push root by the dorsal root ganglion, and then in the gray matter they relay in the lamina 3-4 of the spinal cord on the lateral side. From here, the second order neurons cross to the opposite side, ascend as a Spino-Olivery tract indicated by the cross. In the medulla, these fibers relay in the inferior Olivery nucleus. The inferior Olivery nucleus receives a variety of inputs from the different areas, from reticular system, vestibular system, and from the cerebral, pontine, and the collicular. All inputs are given here, and from here the olivocerebellar tract begins. These olivocerebellar tracts, these fibers, pass through the inferior cerebellar peduncle and relay in the spinocerebellum as climbing fibers. If you are looking at, again, there is a 2 times crossing from once at the spinal cord level, the Spino-Olivery tract, from the Olivery tract, the second order neurons cross to the opposite side, and again from the olivocerebellar it crosses to the opposite side. That means whatever the information the cerebellum receives, it is from the same side of the body. All the 4 direct pathways ascend or reach the cerebellum as a mossy fiber, whereas the olivocerebellar fibers as a climbing fiber. We will look into it in the next slides.